This video is about how to use trapezoidal rules to estimate the definite integral or estimate the area under the curve. First of all, remember this is the rule. So you need to figure out h. h will be b minus a over n. So this is a, here's a b. You will get the 6 minus negative 4 over 5. That is 2. For the I will be a plus hi. So a will be negative 4 plus h will be 2. Then I. You can work this out very beginning like y0 and y sub n. Y sub 0 means f of a. For y sub n equals f of b. You put into graphing calculator, you will get the y0 equals 11 and y sub n equals 51. So we will work xi equals negative 4 plus 2i. For this I, the n equals 5. So get started from 0. Don't forget, it's from 0. Then you need to substitute this number for I so that you can get the value for xi. You can work out for x like this. Then you could see the difference is 2. It's this h. And then for the yi, you just need to substitute this value for x so that you can get the yi. Last step, you just need to plug into this formula. So the estimation of the definite integral or the area under the curve equals 1/2. H is 2. Then y0 plus y sub n will be 11 plus 51. Then plus 2 times 3 plus 3 plus 11 plus 27. Then you put into graphing calculator, you will get 150 will be the answer. So let's work out the definite integral. You will get a prime equals definite integral from negative 4 to 6 x squared plus 2x plus 3 dx. By graphing calculator, you will get 143. Therefore, for the percentage error equals 150 minus 143 over 143 over exact value, remember. So you get the 7 over 143. We put into graphing calculator, you will get 4.90%. When n increasing, then this percentage error will be decreasing. So when n approaches infinity, then this area, these two areas will be equal to each other. Basically, for definite integral, we have the definition by limit. For integral from a to b, f of x dx. I can write down limit n approaches infinity, summation. This I equals 1 to n, and f of xi times this h. Why it only have f xi times h? Because when you divide the interval into n parts, when n approaches infinity, those trapezoid will be rectangle. You can count those trapezoid as a rectangle. That's the reason we do f of xi times h. In other words, the bottom base and then the top base of a trapezoid are equal to each other. When you divide this interval into n parts, this n is infinity. H will be equals b minus a over n. Xi equals a plus h times I. Then I can write down a plus b minus a over n I. We call this is a definite integral by limit. Let's do one more example. The curve y equals square root of x plus 7 from x equals negative 4 to 3 with n equals 4. First of all, we will work out this h equals 3 minus negative 4 over 4. That will be 7 over 4. Then you will write down here the 0, 1, 2, 3, 4. The xi will be negative 4 plus h is 7 over 4i. Then you can fill out this table. Furthermore, you can fill out this yi. It will be square root xi plus 7. After you fill out this table, then you will get the estimated area by trapezoidal rule is here. 1/2 times 7 over 4. Then do bracket 1.73 plus 3.16. Then you need to add this 3 together, multiply by 2. 2.18 plus 2.55 plus 2.87. By GDC, you will get the 17.6. For the A prime, that's the accurate answer for definite integral will be from negative 4 to 3. Square root x plus 7 dx equals. Answer will be 17.6. So they are almost the same. In this way, let me get 2 decimal place. Here's 17.61. This part is 17.58. So that we can work out the percentage error equals 17.61 minus 17.58 over exact value will be 17.61. So equals. The percentage error will be 0.170%. From this problem, you could say trapezoidal rule is a good method to estimate any definite integral. Let's go to the last question. The table below gives information about the function of f. Use the information given to find an approximation for this definite integral. We will use trapezoidal rules to estimate this definite integral. So first step, you need to find the difference of x. This will be the height. Then the second step, you will count, this is y0, y1, y2, y3, and y4. Since the height is different, so you cannot use that trapezoidal rule over here. You just need to figure out each trapezoid separately. So for the area 1 equals 1/2, height is 0.4. Then it's y0 plus y1, 3.8 plus 3.4. Then work this out. For the A2, you will get the 1/2 times 1.1. Then 3.4 plus 2.7. After you figure out A1, A2, A3, A4, you just need to add this together. Therefore, the A equals 1.44 plus 3.36 plus 1.88 plus 0.925 equals. Answer will be 7.61. Since we don't know this function, we only get certain points. Therefore, we cannot get the exact value for this definite integral.